Hello, now we are going to continue on with our work in Venn diagrams and sets, and we're going to look at the universal set today. So the universe is the name we give to absolutely everything in existence. And the universal set is going to be the name we give to a set that has absolutely all of the elements that we are going to deal with in a question. So universal has the same meaning as the universe that we deal with or learn about in science class. So we're going to be learning about the universe that has absolutely everything that exists in it. And then we're going to have the universal set that has absolutely all of the elements that we are going to deal with in it. So let's have a look at this example here. I have capital U is for my universal set. That's the name I'm always going to give to my universal set. Now, again, from our work before, we know that this looks quite like the union symbol. But this is the name of a set. It's going to be off by itself, and it's going to be the definition of a set. The union symbol is going to be in between other sets. So that's the union symbol. That would be M union K. So it's not a capital U. It looks a little bit like it though. But it's going to be in between two other sets because it's going to be linking two sets together. What is in both, or what are all of the elements in M or K is what our union is. Everybody together. So they look similar, but they're used differently. So once we get used to them, we'll be able to see which one we're talking about based on the context that we see it in. But it is something to keep in mind. The universal set is capital U, and union looks a little bit similar. Now, let's translate these English definitions of our three different sets into maths. So we're going to list the elements of our universal set, U. And we open up a curly bracket as we always do. And we're going to have the natural numbers from 1 to 6. Now the natural numbers we're going to talk about again soon. Some of you will know them. Some of you will learn about it soon. The natural numbers are the whole numbers that are positive. So we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, continuing on forever. So they're the positive whole numbers. Now, natural numbers from 1 to 6. And this is going to be our universe. So 1, 2, 3, 4, 5, and 6 with a comma in between each time is our whole universe. That's all of the elements in our question. There can be nothing that comes up that is not going to be an element in that set. So that is all of the elements, all of the members of our universe. Everything we do will be involving these elements here. So that's our universe done. Now let's have a look at our set M. M is going to be the even numbers from 1 to 6. So what are even numbers? They're numbers that we can divide by 2, and we end up with a nice whole number at the end. So what would be a number that we could, the smallest number we could divide by 2, or that is divisible by 2? 2, because 2 divided by 2 is 1. And then our next one would be 4. And our next one would be 6. So those are our even numbers from 1 up to 6. Then what would be our numbers for the set K? And again, you can see I have capital K, capital M, capital U. These are the names of sets, like the names of people. They have capital letters. So we have multiples of 3 from 1 to 6. So the multiples of 3. Well, 3 by 1 is 3, and that's inside of our universe, so we're okay. 3 by 2 is 6, which is okay. And then we have 3 by 3 is 9, but we run into a problem because that is not in our universal set. So we don't include it or any of the other ones. We only have 3 and 6. So those are our number sets all done out. So we now have our sets listed in number form. Now we're going to draw our Venn diagram. Now, because the universal set is a special set, we know that normal sets are drawn with circles. But the universal set, to remind ourselves that it's a special set, we draw the universal set as a big rectangular box. And this is our universe. Everything happens inside this box. Nothing can happen outside the box, because that's what a universe is. So now we have our set M, and M is a normal set, so we're going to have the set M is going to be a circle, and we're going to have the set K, which is going to be a circle as well. It's the set K. And we know that when we're doing our Venn diagrams, what are we going to do? We're going to have our, we're going to start in the middle. We're going to start as close to the middle as we can. We're going to start in the intersection of M and K. Then we're going to fill in all of the stuff going further and further out. So what does that mean in practice? It means that we're going to look at what's in M and K. So M and K, that's called M intersection K. So we're going to start out with M intersection K, the stuff that should go in the middle here. So that's going to be, we go down through M and K and see what is in both of them. So 2, 4, 6 is in both of them. So we can see that 6 is an element in both M and K. So what I'm going to do is write down 6 in my intersection of M and K, because it's inside of the red circle and it's inside of the blue circle. So it's in the intersection between the two. Where they cross over each other is our intersection. Now, once I've done that, I've filled in my center. Now I'm going to fill in what is only in K. So I can see that K has 3 and 6 in it. I already have 6 written in this part of the circle, so now I need to write in 3 in the part of the circle that it only involves K, because 3 isn't in M, so it can't go in the intersection part. So now I have K totally filled in. I have 3 and 6 are inside the blue circle, and 6 is also inside the red circle M. So now let's finish off what's in M. I have 2 and I have 4. Now there's something that we should be shouting at the screen at this point, because I'm missing something, haven't I? I should be putting in dots next to my numbers, because these are elements in a set, and on my Venn diagrams I'm going to put dots in. Now, am I done? I don't think I am, because I know that the universe includes 1, 2, 3, 4, 5, 6. And I've filled in 2, 3, 4, and 6. So where should the rest of my numbers go? They're not in M and they're not in K. Well, let's do this systematically. Let's go through and mark off the ones that we've used. So there's a 3 here, so the 3's been used. There's a 6 here, there's a 6 been used. There's a 2 here, 2's been used. There's a 4 here, the 4's been used. And now that I've been careful, I can very easily see that I just have my 1 and my 5 left over. So there, what's going to go out here? I have 1 and I have 5. And they are the elements that are in the universe but aren't in either M or K. And that's what we can learn from our universe. Now let's do a few quick questions to remind ourselves of what is of our language for sets. So let's have a look at M union K. What's that going to mean? Well, a union is everybody coming together, so it's going to be everything in M and K. And it's best to read this off of the Venn diagram, because we, as always, only write our elements once, and we've already achieved that in our Venn diagram. So M union K is going to be 2, 4, 6 and 3. And we know, because we've been working hard in our maths, that I could have written that as 3, 6, 4 and 2, or 6, 3, 4 and 2, or whichever order I like, because we know that the order of our elements in a set does not matter. Now, what's the other thing that we can look at that we've already learned? We could talk about M intersection K. Well, what's that going to be? That's going to be the elements that are in both M and K. So we must be in both M and K, inside the blue circle and inside the red circle. So remember, intersection is going to be M and K. And is going to be our keyword for intersection when we get into more Englishy style questions, as we will soon. So the only element that is in both M and K is 6. So we put down 6. Now let's use this as an opportunity to talk about some of the tools that we've learned so far. What would that be? Where have we seen that symbol before? It's cardinal number. What's the cardinal number of M? And that's going to be the number of elements that there are in M. So how many elements are there in M? We can read it off the Venn diagram or off of our sets here. We have 1, 2, 3 elements in M. Or we could read it off our list here. 1, 2, 3 elements in M. So the answer there is 3. Now I don't put that in brackets because I was counting elements. So this isn't a set, this is the number of elements in M. Likewise, I could ask how many elements there are in K. So how many elements are there in K, or what's the cardinal number of K? I have 1, 2, or 1, 2 elements in K. So there's going to be 2 is going to be the cardinal number of K. And let's try one more. We can ask ourselves a few questions. So 2. So that's a question. What does it mean if we translate it into English? Is 2 an element of M? And that's true. Yes, it is. So we could say yes or true. 2 is an element of M because 2 is one of the elements in M. Let's ask ourselves another question. 7 element U. Is 7, the number 7, an element of U, the universal set? So we go to our Venn diagram or our list and say, well, no, 7 is not there, so that's false. And how do we write that? It's not an element of the universe. Well, we put a line through it, don't we? So we put a line through element and we say 7 is not an element of the universe. It isn't in our universe. So finally, we're going to have a look at subsets. So how do we write subset? Well, let's try this one here. I need to write a set if I'm asking about a subset. So is 2, 4 a subset of M? And I would say yes, it is, because all of the elements in this 2, 4 are inside of the set M. So yes, 2, 4 is a subset of M. And that's a recap of some of the tools that we've looked at while we've been doing our sets work.